Alright, boys and girls, we're on our last screencast of the day. Hopefully you have completed 8.1, 8.2. If you did complete 8.1, 8.2, then you're ready for 8.3. 8.1 and 8.2 also has a lot of the same stuff that's on 8.3. The only thing that we need to take a look at here is negative exponents, and then we're also going to take a look at zero exponents. Before I move on to go through some notes on 8.3 and talk about how negative exponents work and how positive or zero exponents work, you should be able to figure some of this stuff out. For instance, number 17 is another product of a power, just like you got done working on. Number 18 is a power of a power, where you're multiplying the exponent in. Number 13, the only thing you're going to have to do is change the negative exponent rule, which you'll learn here in a little bit. Same with 12. And should be able to get quite a bit of this. Questions like 20, 21, we'll look at stuff like that. This is a product of a power here, product of a power here. This stuff is very much the same thing. All you need to learn is that negative exponents will make slight changes. Alright? So I've already got some notes started. And you'll need some notes to take here too. It's on 8.3, negative exponents, zero exponents. If you need this paused at any point in time, make sure you raise your hand, let the sub know. They can pause it. And we really need to make sure we get through this so it doesn't hold us up on our other lessons leading into our benchmark. So, lesson 8.3. Let's talk about negative exponents first. If at any moment you have a negative exponent, for example, let's have a base of 3, an exponent of negative 6. Okay? Base of 3, an exponent of negative 6. We need to remember that this number is actually a fraction. Okay? And it is all over 1. Now what the negative exponent does is we have to make it into a positive exponent. And by rule, which I'll prove to you here in a little bit, what you're going to have to do is you're going to have to move this to the bottom. Okay? And so rather than being 3 to the negative 6 over 1, it's going to be 1 left on top and then 3 to the 6th on bottom. And that is all you need to do. If you wanted to, you can multiply this out and find out what this fraction is. But really, in all honesty, I'm fine with you leaving this as an exponent. Okay? Now, the proof of how a negative exponent comes about can be looked at in, let's look at I don't actually see any there where they come about because they're already present with negatives. But basically, here's what's going on. Here's what's taking place. If I have x to the third over x to the fifth, we can agree that I have x's on top and I have some x's on bottom. The number of x's I have on top is just 3. It's x times x times x. The number of x's that I have on bottom are x times x times x times x times x. Okay? We'll recall that our shortcut told us we can take our top exponent and our bottom exponent and subtract them. Whatever that result is on the top of the fraction. X to the negative 2, for example, right? But if we look at the long way of doing this, and the long way of solving, it actually allows us to cancel. And if I had x over x, it equals 1, so it can go away. X over x equals 1, and x over x equals 1. So all I'm left with on top is a 1, and I'm left on bottom with 2 x's. Now, notice if I solve the shortcut way, I have x to the negative 2. So by rule, what this actually means, as we can see in the long version, is that the top of the fraction must move to the bottom. And you'll see, and I have proved that this situation is equal to the long way. Okay? So if we came across the negative exponent right away, it needs to move to the bottom. And there you have number 1. That's how easy these can be. Now if you have a negative exponent or a negative base, it's no different other than you really need to make sure that the parentheses stay with the negative base. And there's number 3. Okay? Now let's jump in and show an exponent of 0. Creating a similar situation to prove a 0 exponent in the way it works. If we looked at the 0 exponent as x to the 5th over x to the 5th. Alright? The shortcut to this would say that 5 minus 5 would become x to the 0. Now, if we draw this out the long way and map this out the long way, let me move the long version over here. I have how many x's on top? 5 of them according to my problem. And I have how many on bottom? Once again, 5 of them. Now if I have 5 of them, we've talked about the fact that these can cancel. X divided by x equals 1. 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 And the last x divided by the last x equals 1. And I have no more x's left on top, no more x's left on bottom. All I have left is 1 times 1 times 1 times 1 times 1. And whatever that answer is equals 1. So therefore, when I have no x's on top, no x's on bottom, its answer is 1. And that is the proof for a 0 exponent. Now, it does not matter what the base is. This number could be 3, 5, negative 6, negative 2, positive 20, 38, 41, 47, 1,396,431. Regardless of this number, if it has an exponent of 0, its answer is 1. And that should really help you out with the answer on 4, 5, 6, 19. And that looks like all of our exponents of 0. Okay? I really want you guys to go through this. Remember that your rules are the same for product of a power, power of a power, quotient of a power if you come across them. The negative exponent just means that if it's on the top, such as it is here, it moves to the bottom. In some cases, it may be on the bottom, such as number 11. And if your negative exponent is on bottom, you must make it positive by moving it to the top. So I've helped you out with at least 6 or 7 answers there. Take this home as homework, give it a shot. If you need to rewatch any of the screencasts and there's time remaining, you can have the sub go back whatever you want to look at. Okay? So here's page 1. If you want to pause it there, you can. And if you want anything from the second page on negative exponents and 0 exponents, There's page 2. Please, please, please give this a shot, because we're really behind already and we can't fall back any further. We're going to miss out on some lessons already that we will be tested on. We need to find a way to get as much done as we can. Thanks and have a good day. We'll see you Friday.